At Year 11, we've got this video here for your homework. It's November 2012 paper, 30th of November 2012, and it's Unit 3. We're going to go right ahead and start with question 1. This paper has, like all papers, a page with your formula in, and we will be needing that later on, so I'm just going to put that to one side for the minute, but you'll need it later on in the paper. So to begin with, you're presented with an inequality. 3x plus 5 is greater than 16, and it tells you that x is an integer. So we're going to find the smallest value of x. So in order to do that, we can treat this inequality just as if it was an equation. So you can imagine this is like an equal sign. Now, of course, we're not going to write an equal sign because this is an inequality. We need the inequality sign instead. So instead, we're going to keep it like this, but deal with it exactly the same. So we're going to isolate the x terms on this side. To get 3x on its own, I'm going to do the opposite of adding 5, which is taking 5 away, to give me 3x is greater than 16 minus 5, which is 11. I'm then going to need to divide by 3 on both sides to get, again, a single x, because that's the opposite or inverse of 3x. That's 3 times x, we want to divide. So that gives me x is greater than 11 over 3. Or I can write that as a decimal. X is greater than 3.6 recurring. Now, because this is a calculator paper, if you need to, you can use a calculator to work that out. So you could do 11 divided by 3 and then press the third decimal button to tell you that it's 3.6 recurring. Now, this question doesn't ask you for this. It asks you to find the smallest value of x when x is an integer, and this isn't an integer. An integer is a whole number, and that can include 0 and it can include negative numbers, but in this case, we're looking for x to be the nearest whole number that's greater than, because of our sign, 3.6. So my answer here is going to be 4. So this is a 3-mark question. So you would get 1 mark for isolating the 3x on its own there. 1 mark for this answer, so either 11 over 3 or 3.6 recurring because they're equivalent answers, and a final mark for that 4 there. Make sure you mark in red pen. Going on to question 2. So this is a forming and solving equations question. It talks about Brian, who is x years old. So first of all, I'm going to make a note that B for Brian is x years old. Peter is 4 years older than Brian, so Peter is Brian's age plus 4. So I'm going to write that as x plus 4. And Amy is 2 years younger than Brian, so that's Brian's age, take away 2. The total of their ages is 26 years, and it asks you to work out the value of x. So what I'm going to do here is write an equation from these that equal to 26. So all of these things added together will equal 26. So Brian's age, add Peter's age, add Amy's age is going to equal 26. Now I just want to collect up these like terms to make this easier. So all of my x's I can add together, and my numbers I can add or subtract. So I've got 3x there, 1, 2, 3, and I've got 4 minus 2, which gives me 2. Is 26. And now I'm going to go ahead and solve that like I would any other equation. So I'm going to take away this 2 to isolate the 3x on its own, because that's the inverse there. So I've got 3x equals 24. And then because I've got 3x but I only want 1, I'm going to divide by 3 on both sides, and that gives me x equals 8. This is a 4-mark question, so you get your first mark for writing a version of this. So you've recognised what P and A are. You get a mark for forming an equation, 1 for isolating the terms, and finally 1 for solving it. So that's where your 4 marks would come from there. So we're going to turn over the page to question 3. We're looking at a question about cake. So we'll read it through. Susan has a round cake. The cake has a diameter of 20 centimetres. So I'm just going to highlight this. It's marked on the picture here, the diameter, which is all the way across from both sides of the circumference there, passing through the middle point of the circle. It's 20 centimetres. The cake therefore has a diameter, and we want to put a ribbon around it. So what we're really talking about here is finding the circumference of the circle. So you're not given the equation for the circumference of a circle in the exam. It's something that you're expected to know. So you should know that the circumference of a circle, so I'm going to write it down, make it really clear to the examiner. So the circumference of a circle is pi times diameter, pi d. Or you might also know it as 2 pi r, which is 2 times pi times the radius. So in this case we've been given the diameter, so we can put therefore the circumference equals 20 times pi, the diameter times pi. So Susan wants to put a ribbon around the cake. What's the least length of the ribbon? Well, now we're going to have to do a calculation to find out what this is as probably a decimal number, I would imagine. So we'll put into my calculator 20 times, and press shift, and then the times 10 to the power of x button, which gives me pi. If I press equals, it's going to give it in the form of 20 pi. I'm going to change it using my surd to decimal button. So that gives me the decimal answer, which is 62.8318537. I'm going to have a look at the question. It doesn't tell me the degree of accuracy that I need to round to. So I'm going to have a look and think what's consistent with the question and what's appropriate in this case. Now, they've gone with integers at 20 centimetres here, so I'm going to go with 62.8 centimetres. Because realistically, if I was cutting that ribbon, I wouldn't go to a smaller degree than a millimetre, really. So that's going to be my answer, and I'm going to put in there that it's to 1 decimal place. So to mark this then, my marks, it's a 3-mark question. I'm going to be able to get a mark for pi times 20, so here. I'm going to get a mark then for showing that as a decimal answer, 62.831, etc. And I get a mark for a unit that's consistent with the answer. So I get a mark for writing centimetres there. So if there's something you really don't want to forget with this question, is to write down your units. So turning over now to question 4. Now immediately when I look at question 4, you can see that we've got 2 boxes on there, and it looks very much like other questions I've seen before about comparing 2 different items. Now having a look at it, there's a star by the 4 here, so that means it's a communication question. In other words, I need to be really, really clear about what I'm saying and make sure my working is done beautifully so the examiner can understand it. So read the question. Gordon owns a shop. Here are the prices of 3 items in Gordon's shop and in a supermarket. So there's Gordon's shop and the supermarket. Gordon reduces his prices by 5%. Now I'm going to highlight that because that sounds like something that's important. I don't want to forget it later. Will the total cost of these 3 items be cheaper in Gordon's shop than in the supermarket? So first of all, I'm going to draw a line down that page. So I'm going to make very clear my 2 sets of working for Gordon's shop and the supermarket. And I'm going to start with Gordon's shop. So first of all, I'm going to work out the total of all of these prices. And this is a calculator paper, but I'm still going to write down my calculation just in case there are any errors and to show with my communication exactly what I'm doing. So I can add together all of these to get me a total of £4.60. So that's the loaf of bread, add the litre of milk, add the 40 tea bags. Now I'm going to come back to what I've highlighted here. So it clearly says that Gordon reduces his prices by 5%. So now I'm going to need to reduce this total of £4.60 by 5%. In order to do that, I'm going to use the unitary method, which means I'm going to work out what 1% of that total is. So to find 1%, I'm going to do £4.60, I'm going to divide that by 100, because 100% would be the full amount. So my answer to that is 0.046. Now, if his prices are reduced by 5%, his original price is 100%, I'm going to take away that 5% to give me 95%. So I'm looking for 95% of the total cost. And in order to calculate that, I'm going to take my 1% of 0.046 and times it by 95. Now, there are other methods of doing this. So you could use a multiplier, and they will be allowed in the mark scheme, but I'm going to focus on this unitary method for now and write down then that the total for Gordon's shop is £4.37. Now moving over to the supermarket, there's no reduction, so it's a lot more straightforward, but I'm still going to write down exactly what I'm doing, which is adding up the cost of the loaf of bread, litre of milk, and the tea bags. So I'm going to pop that into my calculator to give me a total of £4.29. So there's my 2 calculations. Now, the question asks, will the total cost of these 3 items be cheaper in Gordon's shop than in the supermarket? So Gordon's shop is £4.37 and the supermarket is £4.29. So the answer is no. Gordon's shop is more expensive. And for the mark there, it needs to be a clear comparison based on the answer. So I'm going to say that it's more expensive by 8p, because the difference between the £4.37 and the £4.29 is 8p. So then for marks, I'm going to get 1 mark for adding these up. So I don't get a mark for each, just get 1 between them for adding them up. Then I'm going to get an accuracy mark for being able to show that the 2 amounts are £4.37 and £4.29. So if I've got both of those, I get another mark. And then finally, I get a mark for the statement to say that no, Gordon's shop is actually more expensive by 8p. So we're going to question 5. So this is a bearings question. The diagram shows the position of a town, which they've called A, and that town is just here. And town B is 64 kilometres from town A on a bearing of 070. So bearing is always given with 3 numbers, and that just means 70 degrees from the north line. We've got some more important information here, which is a scale, which tells us that 1 centimetre represents 10 kilometres. So I'm going to need to take that scale I'm going to need to use that scale, sorry, when I start to calculate this. So 70 degrees. First thing I'm going to do is measure from 0, from north, around to 70 degrees. I've made sure that my protractor is lined up beautifully there at the end of the line, so the cross on my protractor meets the cross for the A, and that the 0 is lined up with north. And I'm measuring on that outside scale because we're going from 0 around. So that's my line there. And I'm not going to join it up at the moment because I need to be careful to make sure that I join it up with the correct length line. So town B is 64 kilometres from town A on that bearing. So if 1 centimetre represents 10 kilometres, I'm going to need to divide 64 by 10 to be able to find the length of my line. So that's 6.4 centimetres. So I'm going to measure from A along 6.4 centimetres, exactly along this line. So 6.4 is here. So I've gone from A all the way along on that bearing. Now I need to mark that. So it says mark with a cross, and I'm going to put a B there just to be really clear. In terms of marks then, I get 2 marks for doing this in the correct place. So both marks if this is correct. If that isn't correct for any reason, I can get 1 mark for a correct angle and 1 mark for a correct line. So if this isn't correct, it can go down to those individual 2 marks if necessary. But let's hope we just get them all correct instead. So now question 6. We're asked to solve an equation. So having a look at this, I can't solve that as it is. I'm going to need to do something to it first to make it more accessible to me. So the first thing that I'm going to do is have a look at how to expand this bracket. So to expand the bracket, I'm multiplying everything inside the bracket by the number on the outside. So this will be 3 times the first term in the bracket and 3 times the second term in the bracket. So 3 times 2p is 6p. 3 times minus 5 is minus 15. Be very careful there because that's an error that a lot of people will make. To get that incorrect, equals 21. So we must make sure we multiply by the first and the second term. Now I'm just going to go ahead and solve this like I would any other equation. So I want to get my variable on its own. At the moment I've got 6p minus 15 on that side. So I'm going to just add 15 to both sides. So that's the opposite of the subtract that I've got there. To leave me with 6p equals 25 add 15, which is 36. Now to isolate the variable to get p on its own, I'm going to have to divide by 6 on both sides to give me p equals 6. In terms of marks then, for me to have expanded this bracket properly, that will get me the first mark. Then, if I've managed to, well actually I get a first mark for either this or this. So if I've got either 6p or minus 15, I get a mark for that, I apologise. And I get a second mark for it being equal to 21. And then my final mark is for my correct answer. So you have to expand it for the first mark, get it equal to 21 as an equation for the second one, and then solve it for the third one. Now for part B, I have another equation, but this time I've got unknowns on both sides. There's a couple of different ways that you can attack this one, but I'm going to tell you the way that I would do it. So have a look at it, and what I'm looking for is the easiest way for me to answer it. Something that's not going to turn out very, very complicated. So I look for where my largest number of x's are. So I've got 9x on this side and 5x on this side. So it makes sense to me to take away the 5x from the 9x, so that I just get x's on one side. So my first step is going to be minus 5x from both sides. So that leaves me with 4x minus 11 equals 7. And now I'm going to need to try to isolate this further by just having x's on one side and integers on the other. So I've got 4x then, and I'm going to add 11 to both sides to give me 4x equals 7 add 11, which is 18. And now finally, to be able to follow this through, I'm going to have to divide the 4x by 4 in order to come up with my final answer of x equals 18 over 4, or an equivalent answer. So you would get a mark for that, but you would also, if you wanted to put it as a decimal, you'd get a mark for 4.5. So right from the top, this is where your marks come from. So you get your first mark for an attempt to get x's on their own. So this bit here where we took away 5, that's your first mark. You get a second mark for getting as far as 4x equals 18. And then you get a final mark for your answer. X equals 4.5 if you'd rather write it as a decimal, or 18 over 4, or any equivalent answer to that you prefer. So now we're asked to find a length of a triangle, and the first thing that I notice about that triangle is it has a right angle in it. It's really important information as we come to solve this. So I'm having a look at it. It says calculate length AB and give your answer to one decimal place. Well, it's a right angled triangle, and I've got two sides given to me. So I straight away know that I can use Pythagoras' theorem to solve this. And Pythagoras' theorem is that a squared plus b squared equals c squared. I'm going to go ahead and label up my triangle now, and I need to do it in terms of a, b and c. Notice in the question they've already put capitalised letters on the angles. So the way that we label it is that opposite the capital letter, so opposite the uppercase A, we're going to put a lowercase a. Opposite the uppercase B, lowercase b, and likewise C and C. So I've got A, B and C on the insides of my triangle, representing the lengths. Now all I need to do is substitute into this formula, not given to me in the exam, it's something that again I need to know. So if A is 9 centimetres, I get 9 squared plus B squared, B is 14, so 14 squared, and that's going to equal C squared, or the square of the hypotenuse, or this missing side that they've asked me to find. So that's 81, add 196, which if I add those together is 277. So to summarise that, then C squared therefore equals 277. But I don't want the square of the side, I just want C. So I'm going to have to square root both sides. I can do that on my calculator, so I use the square root button here, and I'm going to put in the square root of 277 equals, and it's going to give me it in third form, so I'm going to have to use my third to decimal button, and that's going to change it to 16.64331698. I'm going to write down that whole number just to make sure that I'm very, very clear about what I'm doing. Referring back to my question then, give my answer correct to one decimal place, C therefore equals 16.6. I'm just going to be careful to check that I'm rounding that correctly. Next to the 6 I've got a 4, so it is going to round down. In terms of marks there, my first mark is given to me for the 9 squared plus 14 squared. So as long as I have something amongst these lines here, 9 squared and 14 squared, or 277 seen, then you're going to have a mark for that. Secondly, for square rooting, so showing that you need to square root, that's your second mark. And thirdly then, we're going to get a mark for correct answer, which is 16.6. That's where my 3 marks come from. So over the page. Now this looks like a familiar type question with these 2 boxes on there. In fact, we've had one very similar already in the paper. And here we are again with that all-important star by the question number telling us that this is a question that's going to require us to show very good communication. So we'll read through the question. Sam is going to paint his garden shed. Paint is sold in 2 different shops, Paint For You and Paul's Paints. And we're given information about those paints that we're going to come back to. So Sam needs 7.5 litres of paint. So I'm just going to highlight that. Looks like some key information. He wants to buy the cheapest paint from one of these shops. Which shop should he buy the paint from? So just like in the previous comparison question, I'm going to rule a line down the middle of my page so that my working is very clear between Paint For You and Paul's Paints. So let's have a look at Paint For You. So at Paint For You, paint is sold in 2.5 litre cans at £8.35 plus VAT per can. So the first thing I need to know is how many cans are required. So I'm going to do 7.5, the amount we need, divided by the size of the can, 2.5. So my answer is that I need 3 cans in total. So now I'm going to work out the cost of the 3 cans. Now I am going to bear in mind I need to add VAT on, but I'm going to do that at the end. So 8.35 times 3 is a calculator paper. So I'm going to go ahead and pop that in my calculator, find that that's £25 and 5 pence. So once I've calculated that, I can now go ahead and add the VAT on. There are a number of different ways that I could do this, but I'm going to use the unitary method again. So I'm going to do £25 and 5 pence divided by 100, and that will give me 1% of the current price. So I'm just going to write that down, 0.2505. Now I need to add 20% on. So I'm going to multiply that 1% by 120, because 100% is the cost now, and I need to add the 20% on. So 0.2505 times 120 will give me an answer of £30 and 6 pence. So that's my cost without VAT, and then adding VAT on. Now look over to Paul's Paints. So Paul's Paints sells this small can of 0.75 litres. So notice here we need 7.5 litres. Don't get confused, there's a common mistake there that we might think they just need 1 can. This is significantly smaller. In fact, it's just 1/10 of the size that we need. We'll go ahead and show that by saying that we need 7.5 litres, and we're going to divide it by 0.75. So I can use the quotient button if I want to on my calculator. So the fraction button up here, do 7.5 divided by 0.75, which gives me the answer of 10. So I need 10 cans. So I'm going to do £3.15, which is the price of 1 can, times by 10, which will give me a cost of £31.50. And again, we can do that on the calculator if we want to. So now I've worked both of those out. I'm just going to refer back to the question to be sure that I'm very specific in the answer that I'm going to give. So if Sam needs 7.5 litres of paint, he wants to buy the cheapest paint, he's going to buy from one of these shops. Which shop should he buy paint from? Well, Paint For You is cheaper, so I'm going to say that Sam should buy from Paint For You because it is cheaper. And to put the icing on the cake, we'll work out exactly how much cheaper it is by doing 31.50 take away £30.06. So 31.50 take away £30.06, which gives me cheaper by £1.44. In terms of the marks then, there's a number of different ways, as I said, that you can approach this question. But if you've done a division to find out the number of cans on either one, you get 1 mark. So identifying the number of cans gives you 1 mark. Then finding 1% can get you another mark. And finding the price at £30.06 can get you 1 more. So between this and this, between 2 correct answers, that's your 1 more. And then finally a correct statement. So that's the number of cans, a method to find the 20%, the answers of 30.06 and 31.5, and then a statement, a correct statement to back that up as well. So this is the last one we're going to do on this video. So this is the volume of a prism. So the volume of prisms, the formula for that is given to you in the front of the paper, and it's actually the first thing on the paper here. Volume of a prism equals area of cross-section times length. So I'm just going to write that down. So volume of prism equals area of cross-section, and that's times length. That's me making it very clear that I know exactly what I'm doing. So there are a number of different ways that we can go about doing this, but I'm going to start by finding the area of the cross-section just like it tells me to. So it's this L shape here that I need to find the area of, and in the diagram it shows me that we've got right angles here, so this is made up of 2 rectangles or perhaps a rectangle and a square. So I'm going to start, I've drawn myself a little picture because it's going to make it easier for me to label, and I'm going to start to label the sides. Now we know these are 9 and 7 because it's given to us on this diagram. What I'm going to do is try to work out the other sides that I need. So I'm going to start by thinking about how I split up this shape. So I think I'm going to split it along here into 2 pieces. It really doesn't matter how you do that as long as you're able to piece it together in the end. So I need to find the length at the top here, along the top of the L. Having a look at my original diagram that I've been given, I can see that I've got 2 centimetres here at the matching face at the back of the prism. So I'm going to know that that one there is 2 centimetres as well. Now, likewise, I've got 5 centimetres here, and that matches the height here. So this is going to be 5. Now what remains is for me to work out these missing sides. So if this is 9 centimetres, and this is 5 centimetres, the side here is going to have to be 4 centimetres. 9 take away 5 is 4. If this is 7 and this is 2, 7 take away 2 is 5. So now I've managed to work out all of my missing sides, and I'm going to now split this into the 2 to be able to work out my area of the cross section. So I'm going to label these as A and B just to make it really clear exactly what I'm working on. So I'm going to say the area of A is 4 times 2, which is 8 centimetres squared. What I've done is length times width. Then the area of B. So again, I've got a rectangle, so it's 7 by 5, so 7 times 5, which equals 35 centimetres squared. Now I'm going to do A add B to find the surface area, so 8 add 35 is 43 centimetres squared. So I now have the area of the cross section, and I'm going to need to multiply that by the length, or how far that cross section would extend back. So my final calculation then is that the volume will equal 43 times 8. So in this case I am going to reach for the calculator just to make sure that I get this right. It's 344, and because it's volume, my unit will be centimetres cubed, and in fact it is given to you there. So now in terms of marks, we're going to look through. There are many different ways that you could approach this, but your first mark is for splitting this and getting a calculation, so accurately finding these lengths. So that would be your first mark. You've got a second mark for 43 times 8 in there somewhere, and your third mark is for correct answer. Now if you only put the correct answer, you would only receive 1 mark on this, so correct answer only, you do only get the 1 mark, so please make sure that you fully write down everything that you need to in that question. So we're going to move on to a different video now, so you can go on to video 2 to see question 10 onwards. Hi Year 11, welcome back to the second part of your homework video for the November 2012 3H paper. We're starting here on question 10. Please tune into the other video if you want to see the other half of the paper. So we're going to have a look at question 10, which asks us to reflect shape P in the line x equals 3. So the first thing that we're going to have to do is draw in the line of x equals 3. So I'm looking across my x-axis and identifying at what point will every value have an x value of x, every coordinate have an x value of 3, sorry. So along this line here, whatever these coordinates are, so this is 3, 1, this one is 3, 2, 3, 3. The value of x is consistently 3. Misconception is, because it's x, some people might think that it's got to be horizontal. But of course vertically is where it would always equal 3, so that's not correct. Now we're asked to reflect the shape P, which is here, in the line of x equals 3. So we're looking at, if we had a mirror here, how would it appear? So I take each point or corner of the shape and I'm going to count along to the mirror line and beyond. So I've got a 1 square gap there, so I'm going to go 1 square away on the other side. Then I've got a 2 from this point, so this is going to be 1, 2 away. The top point is 2 away, so it's going to be 2 away here as well. Join up the gaps. I'm going to mark that as the reflection of P. So that would be my answer in terms of marks. You get your 2 marks for it being correct. So I would get 2 marks just for the fact that it's correct. You would get 1 mark if you had this line incorrect, but it was still vertical. So maybe it was here or here, but everything else was correct. Now if we move down to the bottom, this question asks us to describe fully the single transformation that maps shape A onto shape B. So it's important here that it is just one transformation that we're looking for. And in this case, when I have a look at it, it does look like a rotation to me, because you can see that it's kind of moved around sideways from the shape. The shape's kind of tracked around, so this is going to be a rotation, but I need to put down some specific information about it. So for us to be able to get all 3 marks, we're going to need to describe fully, not just that it's a rotation, but the point that it rotates around and how far it rotates. So I'm having a look for a point that it would rotate around, and the way that I do that, so I'm going to select a point of the shape. It has to be the same point. So notice here I've got the 2, the length of 2 there, and a 1 and a 2 and a 1, so it's the corner that matches between the 2. And now I'm going to look to see if I drew a line from them where they would intersect at the same distance. Now have a look at this. This point here looks to be the point of reflection, because I can go along 2 and up, along and up, so that looks to be my point there. So this is going to be a rotation around the point of 0, 1. Now I'm going to need to talk about how much my rotation is. So if I draw lines here, I can clearly see that that's a right angle, and from A to B is anti-clockwise, so it's anti-clockwise 90 degrees. I could go clockwise. If I was to go clockwise, it would be all of the way around here, and that would be 270 degrees. So my marks. I get 1 mark for rotation, about the point 0.1 is another mark, and then a final mark for anti-clockwise 90 degrees. Now the next question, as soon as you look at it, with all the space that it's given to you, these will become very familiar to you by now, I'm sure. This is a trial and improvement question. The equation x cubed minus x equals 32 has a solution between 3 and 4. Use trial and improvement to find the solution, and give your solution correct to 1 decimal place. So for trial and improvement, we always have to do the same thing. I need to draw a table with 3 columns in it. 1 column for my x values, 1 for my equation, which is x cubed minus x equals 32. I want to say whether it is too high or too low. Now in the question, it's given us 2 values of x to start with, so it's telling us there's a solution of between 3 and 4. So my 2 values that I start with are 3 and 4. First time then, I'm going to substitute 3 into this equation, 3 cubed minus 3, and calculate the answer. So of course it's a calculator paper, so we shouldn't have too many problems working out that that's 24. And I'm comparing that to the answer given in the question. We're looking for 32, we've got 24, and so that's definitely too low. Now I try 4. 4 cubed minus 4 again I'm going to pop that into my calculator, equals 60. Compare it to the 32, and that is too high. Now that's as far as the question gives us a clue. We now need to do this on our own and think of the next value that we're going to use. Now we're looking for a solution to 1 decimal place, so we're going to choose a value to 1 decimal place. And I just have a look at this and think, well, 24 is closer to 32 than 60 is, so I'm going to start closer to 3 than to 4. Now wherever you start, it doesn't matter, you can get there in the end. Just looking for a nice efficient estimate rather than a guess to begin with. So on that, from that information I'm going to start with 3.3 and see where it takes me. So I'm going to do 3.3 cubed minus 3.3. So 3.3 cubed minus 3.3 gives me 32.637. Now sometimes I do end up with some quite long decimals, so I have given myself quite a lot of room in this middle column, and it is helpful so I can see it really clearly. It's nice and neat and tidy. And then I'm comparing that to my original 32, which was given to me in the original question. Now that's still just a little bit too high, but it does seem like we're almost there. So I'm going to try 3.2 now. So again, I'm going to substitute that into the equation that I'm given to give me 29.568, which is too low. Now if I draw a diagram to represent these numbers, I've got 3.2 at one end and 3.3 at the other, and I've trapped the value. We know it's somewhere within here. So it's trapped between 3.2 and 3.3, with this end being too low and this end being too high. But I don't know which part of this number line it falls on, whether it's closer to 3.3 or 3.2. So for that reason, I can't round it yet because I don't know. I'm going to have to go in between these two numbers. So I'm going to test 3.25. So I'm going to 1 decimal place further than the question has asked me to do. So 3.25 cubed minus 3.25, pop that into my calculator, gives me an answer of 31.078125. This is also too low. So 3.25 is too low. I therefore know that my value lies somewhere in the top half of this number line, and so x therefore is going to equal 3.3. So for the 2 marks then, you get 1 mark if you've done this trial of 3 and 4, another mark for having 3.2 and 3.3 tried. It's okay if you've got other values as well, but it's those 2 that you need to narrow it down to. Then you need another trial with the 3.25 in it to show that you've gone to that 1 additional decimal place, and then you finally get the 3.3 as a final mark. If you've only got the final answer at 3.3 and no other working, you may get 1 mark, but it's likely that you'll get none. It is very important with this question, of utmost importance, that you write down everything you do. And if you have any other methods using your calculator, be very careful to make sure you record them accurately, because a lot of people lose marks on that question because of using shortcuts on their calculators. So on to a very different question now, about volume. So Ella is designing a glass in the shape of a cylinder. So I'm just going to highlight cylinder there to remind myself. This cylinder needs to hold a minimum of half a litre of liquid, and it has to have a diameter of 8 centimetres, and they've very kindly drawn that on the diagram for me. So now we need to work out the minimum height of glass. So we're looking for it to hold a volume of liquid. So we can use our calculation for volume of a cylinder. Now a cylinder is a special prism. So a cylinder is a prism. Therefore we can go back to our page at the beginning of our exam and find out that the area of a cross section times by the length will give us the volume. In this case, the cross section is a circle. So pi r squared is the area of a circle. So pi r squared times by the length will give me the volume. And in this case, we've been told that the volume needs to be half a litre of liquid. Now having a look at that, I don't really want to use half a litre. It's going to be quite difficult for me to calculate. And so instead of that, I'm going to change that into millilitres. So half a litre is the same as 500 millilitres. We should know that 1 litre is 1,000 millilitres, and so you can half it to get 500. So I've now got pi r squared times length equals 500. Now, in the question we talk about height here, but actually it's exactly the same as length, because I could present my cylinder lead on its side. So don't let that be off-putting to you. just because in the beginning of the paper it calls it length, it's exactly the same thing. It's this cross section or face being replicated all the way down. So this height here is the same as the length. So to make it easier for me, I'm just going to substitute now from the word length. I'm just going to change it to L, and I'm going to mark my diagram with an L as well. Now you could use H if you wanted to, it doesn't make any difference. So let's try to start putting some more numbers into this. Pi r squared, we've been given the diameter, so we can substitute in the radius by dividing the diameter by 2. So pi times 8 over 2 squared times L equals 500. That looks complicated, it's really not. We're just going to simplify that to pi times 4, because 8 divided by 2 is 4, squared times L equals 500. And I think I can go even simpler to say that this is 16, 4 squared is 16, to give me 16 pi L equals 500. Now I'm going to need to isolate my length. So I want to end up with length on its own, don't forget, that's what I'm looking for. So in order to do that, I'm going to divide both sides by 16 pi. Now at this stage, I've just left pi as a symbol and I haven't actually put in a number. If you have, that's absolutely fine. You'll see that it does come out in the end. It's just a preference that I have not to substitute pi in until later on to keep it more accurate. So I've now got L equals 500 divided by 16 pi. Using the quotient button, I can put that into my calculator. So 500 over 16 shift times 10 to the power of x gives me pi. Gives me an answer of 9.947183943. It is in centimetres, so centimetres. Okay, so now I need to look at how I might round my answer. Having a look, it doesn't give me any guidance at all. So in that case, I'm going to round it to 2 decimal places, which would be 9.95 centimetres. And I'm going to just put down there that I've gone to 2 decimal places, so that it's very clear. So in terms of marks there, my first mark is for showing somewhere that I've changed half a litre to 500 millilitres. My second mark is for pi times 4 squared times the height, or the length, it doesn't matter which one you've put, I get a second mark for that. My height or length equals 500 divided by 16 pi gets me another mark, and then I get a mark for my final answer there as well. And I can have anything from 9.9 to 10. Just checking out where that extra mark should be. So I've got 1 for this, 1 for this, perfect, 1 for this, and 1 for this. 1 mark for 500, 1 mark for showing that. Oh, okay. I apologise, another mark here for showing 500. So this mark here is dependent on this part of the calculation, and this mark is dependent on showing 500. That's where your extra mark comes from, so it's 5 marks in total. 1 for showing 500, 1 for pi times 4 squared times height or length, 1 for showing that equal to 500, dividing, and then finding a final answer. Moving on to question 13. So now this is a percentages question about buying and selling a house. Mr. and Mrs. Adams sell the house for £168,000. They've made a profit of 12%. Calculate how much they paid for their house originally. So I'm going to work with the unitary method to do this. If they paid 100% originally and they've gained 12%, the total amount that their house is currently worth is 112% of their total that they paid. So to find 1%, I'm going to have to do 168,000 divided by 112. That will get me 1%, which I can pop into my calculator, £1,500. Once I've got 1%, I need to go back up to 100%, so I'm just simply going to do 1,500 times 100 to give me £150,000. It's exactly the same method as we used previously with the percentages. I'm going to find 1% of the amount and then multiply it back up again afterwards. So your first mark is for this division by 112. Your second mark, multiplying it by 100, and your third mark is for correct answer. If you only put the correct answer there, you would only get 1 mark. Please be very careful to write down all of your workings. This is an interesting question about parallelograms. We're going to read it through really carefully to make sure that we understand what we need to do. So we've got a parallelogram. It's made out of two right-angled triangles by the look of things. We've been given a length here and an angle. So I need to calculate the length of AD, which is this length of this triangle here, from A to D. So the first thing that I'm going to do is think about what I know about parallelograms. So we've got two sets of parallel lines here and here. And we've got equal angles that are opposite each other. So these two angles are equal and these two angles are equal. Likewise, this side and this side are equal, and this side and this side are equal. So the first thing that I can do is jot down that I know that AB is 5 centimetres. That's because of my knowledge of parallelograms to know that those two are equal. Now, I've got a right angled triangle, I've got one side and an angle. So I know therefore that I need to use SOHCAHTOA to be able to work out my answer. So I'm going to write it down to begin with. I write mine down in triangles. The reason for that will become clear in a minute. It's just a nifty little trick that can help you to rearrange these formula. Then what I'm going to do is I'm actually just going to redraw this triangle up this way. And just for me, I feel like that's going to make it easier for me to understand the question. You could turn your paper around, and you just have to be very careful when you're doing this that you get everything in the correct place. So 36 is now at the top, and my 5 centimetres is here. The longest length is the hypotenuse, and because I've got this angle here, opposite is the 5 centimetre side, and the adjacent is the side here that I don't have any information about. So now I need to work out which part of this I'm going to use. So I want the hypotenuse, and I've got the opposite angle. So I'm looking for which one of these sets of information have got the opposite and hypotenuse included in them, and it's sine. So I'm now going to draw out my triangle for sine. So the sine of the angle is the opposite over the hypotenuse. This will help me to rearrange, because here I'm looking for hypotenuse, so hypotenuse equals opposite over the sine of the angle. Now I can substitute in my information, so the hypotenuse equals opposite, which is 5, over sine of 36 degrees. So, using the quotient button, I'll put 5. On the top there is a numerator, sine 36 equals. And that gives me my answer of 8.506508084. And this is in centimetres. The question asks me to give my answer to 3 significant figures. So I'm going to have a look at that. Say my 3 significant figures stop here. So I'm going to have to round up to say it's 8.51 centimetres. That's going to be my answer. So in terms of marks, then, there are a number of different ways that you can go about this, but your first mark is for recognising that AB at the top here is 5 centimetres. I've just been really clear about writing that down. Then, after that, I'm going to need to have a look at using the correct rule. So, if I've been able to show that h equals 5 over sine 36, then that's going to get me 2 marks. There are other ways to go about it. If you wrote down sine 36 equals 5 over the hypotenuse, then that would be one of those marks. But by using the triangle, we've actually just moved across that step. We don't need to put it in. And then you get a final mark for correct answer, which is 81.51. So there are many different methods that you can use for this, and this one I think is the simplest. And if you haven't used these triangles before, to help you to rearrange formula, so you might have used them in science for density or speed, distance, time, then it is worth having a look at using them. And the way I remember that is when I write down my SOHCAHTOA, I'm just lifting the middle letter up, and that's how I can identify what goes at the top of my triangle. So question 15 is a welcome break, really. It's a make the subject of the formula, and what that means is we just need to get m on one side with nothing else touching it, nothing else around. So in order to do that, I need to work out how to get rid of this coefficient of m squared. So my first job is to divide by 6 on both sides, which will leave me with m squared equals k over 6. Now I want to get rid of the squared, so I need to do the opposite of squaring, which would be the square root. So I'm going to square root both sides. So I get m then equals the square root of k over 6. So my answer is m equals the square root of k over 6. In terms of marks, my first mark is here for m squared equals k over 6, and my second mark and final mark is for the final answer. I've got a question on compound interest. Investing £500 on the 1st of January 2000 at a fixed compound interest rate of R. So my rate is R% each year. The value in pounds of the investment after n years is given by this formula. So we're told here that V is the amount of money and that n is the number of years. So my first question is to find the rate. So you'd need to be familiar that this here is the rate. Only, that's it as a multiplier. We're going to write it down as a percentage instead. So this means 1 means 100%, 0.25 would mean that 0.025 rather would mean that we're increasing that by not 2% here, but 2.5%. So my answer is 2.5%, and that's just a 1 mark correct answer. Now I need to use my calculator to find the value of Neil's investment at the end of 12 years. Now we already know that n is the number of years. So I'm just going to substitute into my formula, which I've been given here, n being 12, so the power there is 12. So 500 times 1.025 to the power of 12. So using the x to the power with a little box on there that can just pop that in. And so my answer is 672.4444121. Of course this is money, so I'm going to round it to 2 decimal places because that seems appropriate. Just checking that I'm going to round that correctly. I've got a 4 there, so I'm going to round down. So it is 672.44. In terms of marks, it is a 2-mark question. Your first mark is for putting in the 12 here, and your final mark is for the correct answer, which is here. Question 17, standard form question, comes up in every exam. Write this in standard form. So the first thing I need to know about standard form is that I want something times 10 to the power of something. So I just have to fill in these boxes. Now here, this needs to be between 1 and 10. So I'm going to go with 5.5 as my number between 1 and 10. And then I'm going to count the decimal places that I've had to move to put that decimal point in. So if it was at the end here, I would move 1, 2, 3, 4 spaces, so it's to the power of 4. So it's 5.5 times 10 to the power of 4. And it's 1 mark, so it's just correct answer for that one. Now my next question, there are a few different ways that you could do it. You could change it into an ordinary number straight away, or you could do the calculations and change it afterwards. I'm going to do my calculations first and change it afterwards, so that I'm not dealing with big numbers. So I'm just writing this out without any brackets. Oops, so that should be a 10. So the brackets are not necessary in this case because it's all multiplication, so BIDMAS says that all multiplication can be done together. So what I'm going to do, so I'm just going to do the 3.6 times 5 to begin with. So I'm going to multiply these two together. That gives me 18 times 10 to the power of 9 plus minus 4. When I'm multiplying powers, I can just add them. So that gives me 8 times 10 to the power of 5, because 9 take away 4 is 5. Now I'm going to need to change this into an ordinary number, and to do that I've just simply got to multiply 18 by 10 5 times. So I do it 1, 2, 3, 4, 5 times. So my answer is 1,800,000. Again, there are a number of different ways you can do that, and in fact if you put it into your calculator just as it is, I've just popped that into my calculator exactly as it is, it will come up with the answer in this case. However, it won't always. Sometimes it will come up in standard form, so you need to be aware of how to do it, but it isn't a bad idea to check it that way. Now for this question, if you just put correct answer, you'd only get 1 mark. You needed to show some workings here to be able to get the second mark. So ending up with 18 to the power of 5, that would get you your second mark. If you just tapped it into your calculator, you would miss out. Over to question 18 then, we're going to start looking at vectors, and we're coming towards the end of the paper. So question 18. This is just a sketch, so we're going to bear in mind that we can't use any of this detail to form answers by measuring on this diagram. So that's an important key word there, that this is just a sketch. It gives us coordinate points for P, 2, 4, and for Q, 4, 8. It's asked us to find the vector from P to Q. So this is the vector that we're looking for. here. How do I get from P to Q? So the way that I'm going to need to look at that is I can just simply count how far I go on the x-axis and on the y-axis. And the easiest way to do that is to rewrite these as column vectors. So for P, my column vector is 2, 4. So that's my x value and my y value. For Q, my column vector is 4, 8. My x value and my y value. So in order to get from P to Q, I need to find the difference between P and Q. So I'm going to do Q, take away P to find the difference, which is 4, 8, take away 2, 4. Now to subtract vectors, just simply subtract the top and subtract the bottom to leave me with the column vector of 2, 4. Now there are other ways to do it using your coordinates. So there's just a logical approach that says if this is at x value 2 and if this is at x value 4, well, I know I've added on 2 there. And if the y value here is 4 and here is 8, well, I know I've added on 4. So you can actually work it out from your coordinates as well. But in terms of marks, if you have these vectors written down, you get 1 mark. Or you have your coordinates, you could get a mark for that. So it's one or the other, you can't have both. And then finally, 1 for correct answer. If you only have a correct answer written down, you can only get 1 mark. So again, it's very important to write down all of your working. Now, there are a number of different ways that you can also do the next part of the question. You can actually put these down next to each other because it's useful to be able to see both for this, she says. So, it tells us that M is the midpoint of PQ. Now we know that PQ from the previous question is this vector here, 2, 4. So we've got some information about PQ already. And N is the midpoint of QR. Well, we don't know very much about QR. We haven't got it on a diagram, but we have got a vector for it, which is 6 minus 4. So we've got those 2 vectors that we can look at. Now, having a look at this and thinking about what we could do, the first thing that comes to mind to me is to start to plot some of this information on our original sketch. So if I can improve this sketch, I might be able to use it in order to get some information together. So PQ, we've already got on there. Now it tells me about QR, so from Q to R, I have to go along 6 on the x-axis and down 4. So I'm going to go along 6 and down 4. If I go along 6, this is at x point 4, so if I go along 6, I'm going to be at 10 on x. And this is only a sketch, so it's just rough. And if on y I was at 8 and I go down by 4, then I'm going to be at 10, 4. And so that's going to be my point R. So my QR vector, I can just draw in a straight line here for that. And I've got my coordinate points. Now, we're going to look for the midpoint now, M. So if my midpoint of PQ. So my midpoint is going to be halfway between coordinates 2, 4 and 4, 8. Well, halfway between those two on the x-axis is going to be 3. And on the y-axis is going to be 6. So I'm just looking at halfway between these 2 points and halfway between those 2 points. So that's my coordinate point for that. Likewise, I can do the same for n. So halfway between 4 and 10, halfway between 4 and 10 is going to be 7. And halfway between 8 and 4 is going to be 6. So now I have my coordinates for M and N. So my vector M, N must be the vector for N, take away the vector for M, which would give me 4, 0. And again, I can work that out in other ways, should I wish to. In terms of marks, you can get your first marks, it's 3 marks altogether for this. So your first mark for finding one of your midpoints, and you get a second mark for showing that you know the 2 vectors of M and N, and then a correct answer for 4, 0. So you get a mark for your correct answer. There are 2 different approaches, but whichever way you go about it, you would have correct working leading to 4, 0 as your answer there. So question 19, what a lovely triangle question here. Something tells me we're going to be looking back to our formula sheet. So my first question asks me to calculate the area of the triangle. The first thing worth noting is there's no right angle here and no vertical height given to us. So unless I can calculate a vertical height, I'm not going to be able to use my half base times height calculation. So if I have a look in the front of my paper, I've got the sine rule for the area of a triangle given to me here, which is that half AB sine C will give me the area of the triangle. Having a look here, I've got angle C. Sine C refers to an angle. We've got a capital C there. And I'm going to label up the rest of my triangle with the lowercase a opposite the capital A and the lowercase b opposite the capital B. So now I just need to substitute the values that I've got into this expression. So half times A, which is 14.6, times B, 9.2, times by the sine of 64 degrees. I'm going to be cautious when I put this into my calculator to make sure that I get it absolutely right. So put in a half times 14.6 times 9.2 times the sine of 64 equals, and that's given me an answer of 60.363000815. So I've just written that down in total there. It asked me to give my answer to 3 significant figures. So I'm just going to round this. 1, 2, 3 significant figures would be here. I've got a 6 next to the 3, so I am going to round up to 60.4 metres square. Coming down to the next part of the question, it asked me to calculate the length of AB. Now AB is this long length down here. I'm going to have to be careful here. There is no right angle in this triangle, so I cannot use Pythagoras. What I do have are 2 sides and an included angle. So when I have 2 sides and an included angle, I'm going to use the cosine rule. Now the cosine rule is quite lengthy, so I'm going to be very cautious to write it out. From the information that I'm given at the front of my booklet. Now I'm given one version of the cosine rule, but there are actually 3. And I could rearrange and remember the different cosine rules, but I find the easiest thing to do is to relabel my triangle based on the cosine rule that I'm given in the exam. So in order to do that, I want the side here that I'm after to be A. So everything else now I'm going to cross out. So all the labelling that was on there already I've just crossed out, and I've made the side that I want A, and opposite to that will be capital A. Now with these 2, I'm going to make one B, and opposite that a capital B, and C and a capital C. As long as I stick to that, I'm going to have no problems with using the version they've given to me, and I haven't had to remember anything else. So now I'm just going to substitute into this equation. So A squared equals B squared, 14.6 squared, plus C squared, which is 9.2 squared, minus. Now I'm going to put everything else in brackets. Because of BIDMAS, these multiplications need to be done before the addition and subtraction. I'm going to pop brackets in there just so that I don't make any mistakes with how I put this into my calculator. So 2 times B, which is 14.6, times C, which is 9.2, times the cosine of 64 degrees. So I've been very, very cautious to write that down carefully. Now, all I need to do is pop that into my calculator. So being very careful to make sure that everything is done exactly right. I come up with the answer that A squared is 180.0359751. And of course I don't want A squared, I just want A. So I'm going to square root that answer to come up with 13.41774851. Referring back to my question, it's 3 significant figures that we're after, so that would be 13.4, and my unit is metres, so my answer is 13.4. In terms of marks then, my first mark is here for substituting values into the cosine rule. My second mark is for correctly evaluating this to get 180.085, etc., or equivalent. And then finally, for square rooting that answer and rounding it. So that's my final mark. So just 2 more to go on the paper now. We've got some similar triangles to look at. Now quite often earlier on in the paper you'll get a similar triangle question. So I'm going to anticipate there's going to be a little twist on this one, but we should be able to apply what we know from an easier similar triangle question. So here we go. Triangles A, B, C and D, E, F are mathematically similar. The base, AB, of the triangle is labelled here 2 bracket x minus 1. and the base here of this triangle DE is x squared minus 1. So now we're going to need to work to find the area of the second triangle. Now the first thing that we're going to need to do is go about finding a scale factor. Now in this case it's not going to be an integer or even a decimal number, it's going to be an algebraic expression for the scale factor. To find the scale factor though, we do exactly the same as we would do if we were just dealing with numbers. It's going to be x squared minus 1 divided by 2x minus 1. So, once I've got that, I need to look at whether I can simplify it or not. Hopefully you'll be able to notice that we can have a look at this, the expression at the top here, and recognise it as the difference of two squares, or x minus 1, x plus 1, divided by 2x minus 1. So if we recognise that as the difference of two squares, it allows us to cancel those factors and simplify this to x plus 1 over 2. This is going to make this an awful lot easier for us to deal with. So we now have a scale factor, so this is our scale factor, but this is a scale factor for length. However, we're looking for the scale factor for area. So we're going to need to square our expression here. So x plus 1 over 2 squared will give us our scale factor for area, x plus 1 over 2 squared. Okay, so now we're going to have a look and see how we can use this then to find the area. So if my area here is 4, I'm going to have to multiply this by 4 in order to get the area here. So this simply becomes, so area T equals 4 times x plus 1 over 2 all squared, which is the same as x plus 1 over 4, because 2 squared is 4. So now, because I'm multiplying and then dividing by 4, I can just cancel those out to give me the area of T equaling x plus 1. And now if I multiply that out, I'm going to get x squared plus x plus 1, which is x squared plus 2x plus 1. And if I look at my original equation there, T equals x squared plus 2x plus 1, I've shown that those two are exactly the same. Now, there are again a number of different methods. However, your first mark is going to be for working out your scale factor. Your second mark is for cancelling factors to get x plus 1 over 2. Your third mark is for this here, so recognising it's 4 times x plus 1, x plus 1. And finally, for a fully correct and convincing process, that final mark. There are other methods which you can use involving square rooting. However, I think that's probably the most logical way to approach that question. Finally, simultaneous equation. So I'm going to look at this question by using a method of substitution. So I've got x squared plus y squared equals 25, and then I've got y equals 2x plus 5. So if I call this top line line 1 and line 2, what I'm going to work with to begin with is line 1. X squared plus y squared equals 25. So I'm going to substitute in the value for y, which is 2x plus 5, according to the second line, every time I see y. So instead of y squared, I'm going to put in 2x plus 5 squared equals 25. I've just taken this value from here and just popped it in where y was. Now by doing this, I've only got one variable, so I should be able to just expand this and solve it. So I'm going to change this from 2x plus 5 squared to write this out in full. And then I'm going to need to expand this bracket. So using FOIL, I've got 4x squared plus 10x plus 25 equals 25. And now I'm just going to tidy that up by collecting like terms to give me 5x squared plus 20x plus 25 equals 25. Now, this is a quadratic equation, therefore I really want it to be equal to 0. So I've got a nice convenient thing here where if I take 25 away from both sides, then I'm going to get 5x squared plus 20x equals 0. And now I need to factorise this to solve it. You could use the formula if you wanted to, or complete the square if you want to. There are a number of different methods that you could use to solve this. I'm going to simply factorise it to say that this is 5x times x plus 4, which equals 0. So I've just pulled out my common factors there. And I can go ahead and say that either 5x will equal 0 or x plus 4 must equal 0. So to solve these, this must be x equals 0, because I can divide both sides by 5. Here I'm going to take 4 from both sides to give me x equals minus 4. So I have 2 values here for x. And the question clearly showed me that I would need 2 values. So now I'm going to work out y. And to work out y, I'm just going to split this in half here. I'm going to first substitute x equals 0 into line 2 because it's an awful lot simpler than line 1. So I've got y equals 2 times 0 plus 5. So y therefore equals 5. I'm just going to pop that in the correct line straight away so there's no confusion about where it goes. Again into line 1, I've got y equals 2 times minus 4 plus 5. So y equals minus 8 plus 5, which gives me y equals minus 3. So I'm popping that into the right place there. So my two answers are 0 and 5, or minus 4 and minus 3. So in order to mark that, this is where my marks will come from. I get 1 mark for substituting in the value or the equivalent of y into the line 1. So it's substituting line 2 into line 1. I then get another mark for expanding that to the x squared plus 4x plus 10x plus 10x plus 25 equals 25. Then I get a mark for solving using a correct method. So in this case I factorised, but you could do it different ways. 1 mark for 0 and 5, and 1 mark for minus 4 and minus 3. If you just wrote one correct answer in here, you would just get 1 mark. So if there was no workings, it would just be 1 mark. That's the end of the paper. Remember to have completed everything in red pen or another coloured pen, corrected everything and hand it in on the correct date, which will be Friday. Thanks very much.